Right, we're now going to have a look at how we can classify alcohols. So classifying is something that we've done before when it came on to carbocations. So we classified carbocations as primary, secondary or tertiary. And that's something we're going to do with our alcohols as well. And the reason we do that is because we need to look at what type of alcohol we've got, because one of the reactions that alcohols undergo is oxidation. And each different type of alcohol will undergo a different reaction when it comes on to oxidation. And that's why this is an important skill to have, of being able to classify the alcohols. So I'm just going to run through the three. So again, we've got primary, secondary and tertiary. So a primary alcohol is where the carbon to which the OH group is attached to is only attached to one other carbon, and therefore it is also attached to two hydrogens. So anything can be happening over here. You could just have a CH3 here, or you can have a long carbon chain, doesn't matter. The main thing is that the carbon to which the OH is attached to is only attached to one other carbon, and therefore two hydrogens. So this here is what we mean by a primary alcohol. The next one is therefore a secondary alcohol, and a secondary alcohol is one where the carbon to which the OH is attached to two carbons and therefore one hydrogen. So again, anything can be happening over here, it doesn't matter, as long as this carbon here has two carbons and one hydrogen attached to it. And this is a secondary alcohol. And the last one is therefore a tertiary alcohol. So this is where the carbon to which the OH is attached to is bonded to three other carbons and no hydrogens directly. Okay, so there are no hydrogens directly attached to this carbon, and therefore this is an example of a tertiary, not an example, but this is a skeleton for a tertiary alcohol. Okay, so let's now go through examples of each. So let's firstly start off with a primary alcohol. So the simplest primary alcohol that matches the definition of what I've just said is ethanol. So primary alcohols, we've got ethanol here. So ethanol is a primary alcohol because the carbon to which the OH is attached to is only bonded to one other carbon and two hydrogens. So ethanol is an example of a primary alcohol. Another one could be this one here. So this compound here, you've got three carbons, alcohol attached to carbon number 1, so this is propan-1-ol. Sorry, that one was ethanol. So propan-1-ol, the carbon to which the OH is bonded to is only bonded to one other carbon and two hydrogens, and therefore propan-1-ol is an example of a primary alcohol. Now, one exception to this, or to classification of alcohols, is methanol. So methanol is actually the simplest alcohol. Okay, so ethanol is not the simplest alcohol, it is methanol. So the structure of methanol is this. So if we look at the carbon to which the OH is attached to, it is not bonded to any carbon, it's actually bonded to three hydrogens. And this is the only alcohol that will do this. So technically, this doesn't fit any of the descriptions I've given. This doesn't fit the description of a primary, a secondary, or a tertiary alcohol. But by default, we classify methanol as a primary alcohol. Okay, so even though it doesn't fit that kind of definition I gave earlier, methanol is an example of a primary alcohol. Okay, just by default, because we've got to put it into one of the groups. So therefore, in terms of its reactions, we'll see later, it does behave as a primary alcohol. Right, if we now look at secondary alcohols. So secondary is where we have 2 carbons bonded to the carbon to which the hydrogen is bonded to. So this, the oxygen is bonded to. So this one over here has got 3 carbons and the alcohol is coming off of carbon 2. So this is called propan-2-ol. So if we look at the carbon to which the OH group is attached to, this is bonded to 2 carbons and 1 hydrogen. So that makes this a secondary alcohol. If I just do another alcohol, so this one here is called 1, 2, 3, 4, 5, 6. So this is called hexane. And then 1, 2, 3. So this is hexane 3-ol. So hexane 3-ol, if we look at the carbon to which the OH group is attached to, you've got 1 carbon here and then you've got 1 carbon here. So this is bonded to 2 carbons. And therefore, this is a secondary alcohol. Okay. Let's have a look at tertiary alcohols. So the simplest tertiary alcohol I can think of is this one. So this one here, in terms of its name, the longest carbon chain is just going technically across, or you could go that way, but either way it's going to be the same. 1, 2, 3. So this is propan. The alcohol is coming off of carbon 2, so it's propan-2-ol. But we've also got a methyl group coming off of carbon 2. So this is called 2-methyl propan-2-ol. And because the carbon to which the OH group is attached to is bonded to 3 carbons directly, this is an example of a tertiary alcohol. I'm just going to do a random example of another one. So this molecule over here, the carbon to which the oxygen is attached to is bonded to 3 carbons, so 1 here, 1 there, and 1 there. So this here is also an example of a tertiary alcohol.